Hello, my name is Anthony Betts, and this video is on Section 3 key principles. So I'm going to use this video to first of all give the introduction of how Section 3 is going to work, and then I'm going to go on to what this video is actually about, which is actually true shape and true length. So Section 3 is going to work where the first slide is going to be understanding the key principles, while the second slide is going to be on how to solve the key principles. Because obviously before you solve the key principles, put them into practice into questions and solving questions, you need to understand what you're actually doing. So, true length, true shape. I put those together as one because if you find true shape, you actually know the true length. So I'm going to put that as one principle. That's why I have a little slash between them. So I use University of Limerick, the main building with the glass slope. You can see right here with the picture. And I'm going to go onto Google Maps. Since I'm using a video, I can actually go onto Google Maps and talk about it while I'm using this. So if you're right in the middle of the, I don't know, not courtyard. If you're directly in front of the glass slope, you get the elevation of the main building. I drew out a sketch of it right here. This rectangle right here is the glass slope. This part and this part is the two concrete / glass buildings on each side, which is, if I put this down, is right here and right here. But we're just going to focus on the slope, which is this part right here. If you never did these geotechnical graphics, you would probably think the elevation or the front view when you look directly at it, that must be the true length. Well, I've written right here, not true length, and I will asterisk may emphasize that. So from this point here, from A, and I have a line that's orange, it goes from there right down to here, and obviously goes up and across to B. None of that's a true length. To get true length, you actually need to rotate it. You need to rotate it to the ground. So when I mean rotating to the ground, I mean that when you look at a particular object, or since I'm doing roof geometry, I'm looking at roofs and buildings, you need to rotate it to the ground so you can get the true shape and the true length. So what I'm going to use just to help explain it more, I'm going to use this set square, and I'm also going to move this slightly down to make it easier. This piece of paper that's white, that's on my laptop, I'm going to make sure that this white is the white piece of paper is the ground. So if I lay right here, pushing against the my little sketch I did, it's going to resemble the ground. So this set square, if I put it right here, this is the slope. Oh, it's not fully in the camera. Sorry, let me just bring this out a bit more and push this down. There we go. So this is the slope of the glass building. If you look directly in front of it, from this point to this point, which when this actually goes across, this is the height right there, which is from, if I get my pencil, from here to here, which is here, and then bring this length across, that's the height. So that is that. And we know that's not the true length. The true length is actually the edge view, which is going to be another video as is shown in the key principles on the PowerPoint. That's right here. This is the edge view, because when you look at it, it's just a simple line, but it's the true length. You know this is completely correct, and you know this is the length of it. So to find you have now the true length of the height of a building. So this is the edge view right here. We know the length for this, but we want to know the length from here to here, and from B over to here. So we also need to find the true shape. We only have a small part of the answer, because more than the whole thing. So to find it, like I said earlier on in this video, is to rotate it to the ground. So if we grab our sloping part of the building, which is actually the set square, if we get and we rotate it all the way across and flat, it rotate all the way down and boom, it's on the ground. We now know, if I bring this up and show you, while it's on the ground, we know the true shape of the roof, because I'm doing obviously the glass slope of the UL main building. So imagine, if I bring this camera now closer, there we go. So if you were standing right here and you saw the elevation, you know this is not now. You now know this is not the, sorry, focus, please. You now know this is not the true length. And if you were right here and to find the true shape, I keep saying true shape and true length. I'm going to say true shape because that's a true length isn't a true shape. If you want to find the true shape of this glass building, you now know from standing right here or anywhere around it, you're not going to find it. What you're going to need to do is rotate it all the way down, bam, onto the ground to this pathway, like the set square. When you get it and you rotate it till boom, it hits the ground. I use my hand there, it's from the set square. If this was the glass slope, you rotate it till boom, it's on the ground. And then when you look down at it, you find the true shape. Okay, I don't want to make this video too long. That's it. I'm going to use another video to solve a question of it, but that's the understanding of it video. Okay, bye. Thanks very much.